Malware and the cybercriminals that use it have grown increasingly sophisticated in recent years, becoming stronger and harder to detect. Limitations of existing techniques. Signature-based approach fails to detect zero-day attacks and fails to detect threats with evolving capabilities such as metamorphic and polymorphic malware. Anomaly-based approaches, it produced high false positive rate. In the past, humans had to look at large data sets to try to distinguish the good characteristic from the bad. With machine learning, the computer is trained to find those differences, but much faster with multidimensional signatures that detect problems and examine patterns to identify anomalies that trigger a mitigation response. In order to more successfully combat such attack techniques, cybersecurity engineers have begun to create software that is capable of adapting and learning about its environment and making it easier to spot malicious programs and identify suspicious behavior. The main premise behind machine learning is matching patterns. When you look at malware, you may not see any patterns, but when you look at 500 million samples, there may be tons of patterns that are relatively easy to discern. The goal of this model is to find these patterns. One of the most beneficial aspects of cybersecurity tools that employ machine learning is that they can help users stay ahead of malware that is becoming increasingly polymorphic. For example, if a malware author creates a new variant of an existing program a few months down the line, a security module using machine learning should be able to detect the new strain because of its predictive capabilities. Defense solutions that are based on recognizing known malware strains do not have this ability, leaving many users vulnerable to frequently updated malware. Using two-level learning approach, it first applies supervised learning approach to detect malicious flaws and further identify specific types. If only use supervised learning approach, it suffers poor performance on new and evolving malware. And building classifier model is challenging due to the diversity of malware classes, imbalanced distribution, and data imperfection issues. Hence, it combines unsupervised learning to address new class discovery problem. Deep learning approach is a more granular form of machine learning, or used in malware detection, allows the application to scan files it has never encountered before and detect malware. Deep learning trains the application software using legitimate and malicious files, teaching it which is which. By learning to recognize certain patterns and hallmarks, the application is then able to categorize files it has never encountered before. Anomaly detection, mostly done through rule-based heuristic approach. It is fundamentally different from other machine learning problems. Very high cost of errors. Compared to other machine learning applications, anomaly detection is very intolerant to errors. Really bad if we have a high false positive rate or high false negative rate. Lack of training data. Label data are very scarce and expensive, and it is hard to clean input data too. Semantic gap. Detection is not enough. It's hard to interpret the results or alerts. Okay, I got alert, but why did I get alert? Difficulties in evaluation. Devising a sound evaluation scheme for anomaly detection is even more difficult than building the system itself. Adversary setting. The advanced actors can or will spend the time and effort to bypass the system. The real-world anomaly detection system failed due to the following reasons: many false positives, hard to find attack-free training data, used without deep understanding, model poisoning, through manipulation training dataset to change the decision boundary, which in turn degrades the system performance.